Being able to test a trading strategy on historic data is really useful to quickly see how it performed in the past. There are existing tools and libraries for backtesting, but I'm going to show you how to quickly set up a simple backtest completely from scratch. The first thing you're going to need to do is install Python. So head over to python.org, go into Downloads and download the latest version of Python. Once that's done, go ahead and install it, but make sure that you tick this box at the bottom that says Add Python exe to Path. This is going to save a lot of issues later down the line. So once this is ticked, install now and go ahead and install your Python program. Once that's finished, we need to install a few of the libraries that will be used for backtesting. So bring up the command prompt by typing cmd and then use the pip command to install the necessary libraries. You type pip install yfinance. Yfinance is the first library that we'll need, and it allows us to download data straight from Yahoo Finance. That'll take a couple of minutes, but once that's finished, we go ahead and install the remaining libraries. The process is the same. You just type pip install and then the name of the library. The libraries I need to install are pandas, numpy, matplotlib, and notebook. After that, you're going to need an editor to type your code in. I use Visual Studio Code, so I'd recommend that one if you just head over to download and follow the instructions to install it. And finally, inside Visual Studio Code, there's a few extensions we need to install. So you click on this button here and you search for Python as well as Jupyter. That's the two extensions that you will need to start with. Now we can finally start writing some code. So head up here and create a new file. The file type that I need is a Jupyter notebook, this last one at the bottom, which has the file extension ipynb. Then you can go ahead and save this file somewhere. Now I can start building out this backtest. I'm going to be testing a moving average strategy. So I'm going to begin by defining a few variables. The first variable I need is my starting balance. I will set this to 1000, but it really doesn't matter. So you can set this to whatever you want. Next, because it's a moving average strategy, I need to define a period for the moving average. This variable will be called MA, and I will just set it to a 200 period to begin with. Now I can load in my price data from Yahoo Finance. I'm going to load about 10 years worth of data, and for this I will need to use an additional library. I will add another cell above this one by clicking this plus code button, and up here I will import my libraries. The one I need at the moment is datetime. So I'll say from datetime import datetime, and while I'm here I will also import yfinance as yf. This is just standard shorthand to avoid having to type the whole thing every time I use it. Now I add another code cell underneath everything, and here I can define my data set. So we'll call this daily data because I'm going to be testing on the daily time frame. I will define my start date first, and this is where that date time module from before comes in. I will set the year as 2015 and it will be the 1st of January. Then I can copy this down and create a new variable called end, which I will set to 2025. So this is 10 years worth of data. I will specify the ticker as Apple, and then I will create a variable for my interval, which is going to be 1D. So it's going to be on a daily time frame. With these defined, I can create another code cell underneath, and this is where I actually download the data. I will save the data inside a variable called price, and I will call the Yahoo Finance library with a download function. This takes a bunch of different variables. The first one is tickers, and I've already defined my ticker as Apple. Then we've got the start date, which is all defined. So I'm just going to go through these. End is end. And then I've got the interval, which is also specified as daily. And lastly, there's an additional flag that I like to set, which is multi-level index, and I'll set that to false. Don't need to worry about this one too much. It comes more useful when working with multiple tickers at a time. But since we're just working with one, I'm going to set this to false. When I ran this, I noticed I made a typo in how I spelled Apple. It should have been 2 A's instead. So if I run all of this code now, I get 100% 1 of 1 completed. So the price data has been downloaded, but I can't see it. If I just type price at the bottom, it's going to print out a data frame containing all of that price data, or at least the first 5 and the last 5 values. And that's fine, but it's much easier if I can see it plotted out. But before I plot it, I need to import one more library. Here I will say from matplotlib import pyplot as plt. So I head down, create a new code cell, and here's where I'm going to plot that same data. First of all, I'll create my plot. I'll say plt.figure, and inside here, I will define the size. So fig size is equal to 12 by 6, so width and height. Next, I choose what I want to plot. So I'll say plt.plot, and what I want to plot is the close prices. So I access my variable price, which is where I've downloaded everything into, and I look for the close column. And lastly, I just say plt.show. I run everything again, and now I get my plot of the Apple price chart from 2015 to 2025. And this looks exactly the same as the chart on Yahoo Finance. Now I know I've got the data correctly downloaded. I want to start working with it and getting some information back from it. I'll add a new code cell, and here I'm going to calculate daily returns. I'll create a new column in my price data frame, which will be called return. And return will be calculated by dividing the close price in a row by the previous close price, which I can access by shifting by 1. So for every day in my data frame, I will divide today's close price by yesterday's close price and calculate the return from that. But since on the very first day, there is no previous day, it means that the first day's return has to be manually set to 1. So I will access the return column at index 0, which is just the very first value in a data frame. And I will set that to a value of 1. Now that I have my returns and I have a starting balance, let's see what happens if I invested that starting balance on the very first day and how much I would be left with on the very last day. I can create a new column called bench_bal for my benchmark balance. And this will be the starting balance, which I defined earlier, multiplied by these returns. So that's price.return, but I need all of the returns throughout all of the years multiplied by each other, which is the cumulative product, written as cumprod. At the end of this, if I just output the price data frame again, this time I can see the original columns as well as the return column and this benchmark balance, which shows that when I started with 1,000 on the very first day, on the last day I have 10,285. A pretty substantial gain on that stock, but that's over a number of years. I want to zoom in a little bit and see what the annualized return was as well as the maximum drawdown. I'll move on to another code cell for those calculations. I firstly need to work out exactly how many years are between the start and the end date. I will take my first timestamp, which will be equal to my price index. The index is this first column here, which are my dates. And I look for the minimum value, so the earliest date in that data set. I then do the same thing for my last timestamp, which is going to be the same index, but this time I'm looking for the maximum value. Once I have the min and the max, I can calculate the number of years. And the number of years is, well, it's the two of them subtracted from each other. It's the last timestamp minus the first timestamp. Then I need the number of days in between those two timestamps. And I divide the whole thing by 365 and a quarter to account for leap years. So if I print this out, I will see that it's exactly 9.9958 years. So I knew that it's 10 years, but it's good to get this calculated in a variable rather than manually typing 10. Now I have the number of years, but I need a little bit more information for calculating drawdown. Drawdown is how much the balance has dropped from a peak value. That means that first of all, I need to calculate the peak balance. I'll create a new column called bench_peak. This will be the peak balance for the benchmark. And that's just taken as price.bench_balance.cumulative max. So the maximum value at any given row for that bench balance. And the drawdown is going to be the difference between that peak and the current balance. Another column here for bench_dd, and that is equal to price.bench_bal, which is an existing column. So we've just created that column in the previous cell. So I can access it by just calling my price variable, put in a full stop, and then the column name. And I subtract that value from the peak balance, which is bench_peak. and is the column that I just created in the row before. Now I'm ready to calculate my annualized return and drawdown. The annualized return for the benchmark uses a pretty simple formula, but when it's typed out, it looks quite messy. I need to take my end balance and my start balance. I divide them by each other. To access them, I go into the price variable, the bench bal column, and then I look for the index location. To get the last value in a column, the index is always -1. That's always the last value. And I divide that by the first value, which is the same thing, bench underscore bal dot iloc, but this time I'm looking for the very first value, which is 0. Once I have these, I put them all into brackets and I put them to a power of 1 divided by years. That's the number of years that I just calculated up here. Now I wrap all of this in another set of brackets and subtract 1 from it, then another set of brackets, and I multiply it by 100, and that should be enough to be able to display this benchmark. So this shows me that the annual return for that strategy is 26.25%, but it's given me way too many decimal points. So the last thing I want to do here is round that. So round, then another set of brackets, comma, and we'll just do 2 decimal points. Run it again, and now it's much neater. So I've got the annual return. Now let's do the drawdown, which is a little bit easier. The drawdown for the benchmark is effectively these 2 columns divided by each other, but expressed as a percentage. So we'll take price.bench underscore drawdown divided by price.bench peak. I wrap this up in a set of brackets because I'm looking for the worst value. So it's going to be the minimum, but that's effectively the maximum drawdown because this will be a negative value. And then I will need another set of brackets to multiply this by 100 to convert it into percent. And lastly, just like I did with the annual return, I need to round all of this. So we'll round it to 2 decimal points. So let's see what that looks like now. DD underscore bench. That gives me a drawdown of 38.5%. Now I can present that a little bit nicer. I can type print and we'll say benchmark annual return is CAGR bench percent. Then do the exact same thing, but this time it's benchmark drawdown is equal to DD underscore bench. So now I've got the same metrics from before, 26.25 annual return, which is great, and 38.5% drawdown, which is not so great. So far, I've been processing and working with the existing data from Yahoo Finance. But next, I want to apply the actual strategy to it. So I create another code block, and this is where I calculate indicators. There's only one indicator for now because I want to keep the strategy simple, and this is going to be the MA. So I want to calculate my moving average. Well, the moving average is just an average of the previous X number of close prices. I can say price.close.rolling, which carries out a calculation of multiple rows. And inside here, I specify the window, which in my case is MA, the variable I defined at the start, and that's my moving average period of 200. And lastly, I want to apply an average to it. So I say .mean. If I print out my price again, I get the columns from before, and now I have my moving average. The first few rows are empty because it needs to accumulate enough data before it can calculate a value. But then towards the end of the data frame, you can see that there is a moving average being calculated. This strategy will just have one rule. It will be a trend following strategy. So when price is above this moving average, I'm going to be long in the market. And when it's below the moving average, I will exit the trades. So I need to create conditions that determine whether I should be in a trade or not. I will create a new column called long, and the condition for that will be that my close price needs to be greater than the price of that moving average. Now I'll output the price data frame one more time. And now we can see this new column has appeared. To start with, there are no values, so the long variable is false. But towards the end, we can compare the close is 258 almost, and the moving average is 211. So in this case, the close is above the moving average, and we have a long signal. As long as the value in this column is true, the system is going to be in the market. I'll create a new cell underneath, and I'm going to plot this out again. So I'll create another figure, set the fig size just like I did previously to 12 by 6. And this time I'm going to plot a couple of things. So the first one is going to be my close price, and the second one is going to be the moving average. So price.ma. If I plot this out, I can actually now see my price from before as well as this 200 moving average. I can see the crossovers between the price and the MA, and I know where I'm going to be in the market and when I'm going to be out of it. Now that I have those conditions, let's calculate the return for the system. I'll do that in a similar way to what I did with the benchmark. I'll create a new column called sys_ret for system return, and this is where I will use NumPy. I haven't imported it yet, so I head all the way back up and I import NumPy as NP. I need to make sure that I rerun the cell, so I'll press Ctrl Enter, and that executes this and imports this additional library. Now back into this cell, my system return is going to be using np numpy.where. This is a logical statement that effectively checks for a condition and then it updates the values in this new column based on that condition. The condition I want to know is whether I have a long signal. I created this column just previously in here, which determines if the close price is above the moving average. And that gives me a value of true in this long column. So if I get a value of true on a particular day, then the next day I enter the market. So I need to account for this offset, that I get my signals from yesterday for today's trade. Here I'm going to look for my long column, but I will shift the values by 1. So I am accessing the previous row's signals to determine what to do today. If these values are true, then the system return for the day is the same as the benchmark. It's the return that I calculated earlier under this column. But if the value is false and I'm not in the market, then I just set the return to 1. It means there was no profit and there was no loss. And now that I have the system return, I can calculate the system balance. So I'll create a new column called sysbal for system balance. And I just take my starting balance from before, multiply it by my system return. And again, I need the cumulative product. So cumprod with brackets at the end. That will give me new values, which I can now output by printing my price data frame. So here I've got my system return and a system balance, starting off with 1,000 and ending up with just shy of 5,000. So actually quite a lot less than the benchmark. Now let's plot both the benchmark and the system on one chart. I'll create another figure, PLT figure, fig size is going to be the same as before, 12 by 6. And I want to plot, first of all, my benchmark balance. So that's bench_bal. And because I'm plotting a couple of things, I want to add labels to them. So the label for this will be benchmark balance. And then I'll just copy this down for the second row, which is going to be the system balance. So sys_bal. The label is going to be system balance. Now, because I've got labels, I'm going to call plt.legend, and then we say plt.show. So I run this again, and now I get my blue line, which is the benchmark balance, and the orange line is the system balance. And this verifies what we just saw in the data frame. The strategy of buying above the moving average and selling below it ends up with a much smaller balance in the end than just buy and hold did. So this gives me my first backtest, and this took a little while to set up. But now that it's built, I can test things very quickly. So I can see that the 200 moving average didn't work, but I can very easily try different values. So let's change this to 20 and see if a more responsive moving average makes any difference. And I go down here, and now suddenly that performs better than the 200 did. Likewise, I can change the date range, the ticker, the starting balance. All of these variables are very quickly retested because the backtest already exists in this code. And it's a very useful tool to have because it allows you to test out strategies and see for yourself whether they've worked in the past or not. Now, this backtest logic was simple in the sense that it didn't use any stop losses or take profits. That gives an additional layer of control over the strategies. And if you want to learn about how to add stop losses and take profits, then let me know in the comments and I can do a follow-up on this where I add that functionality.